To another chemistry video, AP chemistry, regular chemistry. This video should apply to all those different types of classes. And so today we're going to be going over Lewis dot structures. So to create Lewis dot structures, we're mostly going to be looking at the periodic table here, and we're going to more specifically be looking at the amount of valence electrons that each element has. And that's the way you see that is by this number right here. So group 1 is going to have 1 valence electron, 2 valence electrons. You're going to skip the D block for now, the red part, because those will have different amounts. And this is going to have 3, 4, 5, 6, 7, and 8 for the noble gases. Alright, so like I just said, hydrogen, which is in group 1, is going to have 1 valence electron, so you're going to just draw an electron on any side of it like that. Something like lithium is also going to have 1 because it's in the same group, the same column that goes down. And so it's going to have 1 valence electron, and it doesn't really matter where you put the dot when there's only 1 or when there's only 2 or whatever. So like this one, carbon, it has 4 valence electrons. You're going to put 1 dot on each side. For nitrogen, because it has 5 and obviously there's 4 sides you can put it on, you're going to have to double up one of them. And when you double up, that actually makes one of them stable. One of the 2 electron pairs stable, and basically what that's going to mean is they don't necessarily want to bond with any other electrons. So for something like argon, it has 8 valence electrons. It's a noble gas. It's super balanced, super stable, and so it doesn't really want to form any bonds with anything else. And that's why noble gases typically don't really want to form too many bonds with other things. So when you have 2 different elements that have open valence electrons, only one that they want to pair with each other, they can form bonds. So for this one, hydrogen can just make a bond with another hydrogen because there's one spot for them to do so. For this one, hydrogen has 1 valence electron, and fluorine right here has 7, and that means that 6 of them are paired together in groups of 2, and so they don't want to make bonds with each other. But then there's going to be that one extra that does want to form bonds, and so it's going to combine with the electron from hydrogen, the 1 electron from hydrogen that does want to form a bond, and it's going to pick a bond. And so that's how you'd show the electron dot structure. So for an example, oxygen has 6 valence electrons, so it's going to have 2 pairs of 2 and then 2 more on any side. And what's going to happen is H2O, since there's 2 hydrogens and 1 oxygen, there's going to be 1 oxygen, and the 1 electron on the end of the 1 oxygen is going to make a bond with the electron with the hydrogen, and the other electron on the oxygen is going to make another bond with the other hydrogen. So the location, again, that you put the electron doesn't really matter as long as you show that the correct amount, you know. So this one can be either this one or it can be this one. So you can have more than 2 bonds, of course. So since carbon has 4 open spots to form a bond, it can form 4 bonds with 4 different atoms. So in this case, since hydrogens each have 1 valence electron and carbon has 4, it can form a bond with 4 different hydrogens at once. And so try pausing the video and see if you can think about the electron dot structure, the Lewis dot structure for C3H8. Okay, hopefully you guys thought about it, and if you didn't, it's fine because I'm going to show you right now. So there's 3 carbons, a little carbon chain going on, and then there's going to be some hydrogens basically attached to every single side on those carbons. Okay, again, just another example. Helium is actually a little bit different because although it is in group 8, it only has 2 electrons to begin with, so it can only have 2, so it's like that. So it doesn't have 8 valence electrons all around it. It just has the 2 that are paired together. And the reason they're paired together in this one and not like 1 here and 1 on the other side is because it still is a noble gas and it still is stable. And the reason for this is because the first electron shell only holds 2 electrons. And so basically, because helium only has 2 electrons, then the electron shell is full and so it's stable. So this is your way of indicating that. Okay. If you're bonding 2 oxygens together, because they both have 2 open bonds, they're actually going to form what's called a double bond. So this electron will bond to this one will bond to this one. So you'll get a double bond. And the same thing applies to nitrogen. Since there's 3 open, this will bond to this will bond to this, and this will bond to this. And so you'll be able to get a triple bond. And so I think that's all we're going to have for today. If you enjoyed the video, leave a like and stay tuned for the next one.